All right, guys, this is lesson 5.4. If you haven't been paying real close attention, 5.4 is going to look almost identical to 5.3. So you're thinking, wait, haven't I seen this video before? You haven't. This is 5.4, but it looks a heck of a lot like 5.3. And so if you got 5.3, this is going to go very, very smoothly. If you didn't get 5.3, watch closely, because this will be a kind of a repeat of 5.3. Instead of using cosines, we use sines. Okay. So just like 5.3, when we asked about cosines, our question comes up with sines. Do you think it's okay just to add up sines? So you think the sine of 10 plus the sine of 20, do you think that's going to equal the sine of 30? Do you think you can just add those up? Remember the answer for cosine? The answer was no. Do you think it'll work for sines? And let's try one we know. So what's the sine of 90? It's 1. What's the sine of 45? Remember, it was square root of 2 over 2. What's the sine of 45? Square root of 2 over 2. How much is the square root of 2 over 2 plus the square root of 2 over 2? That's the square root of 2, which is not the same thing as 1. So can you just add up sines? Probably no big surprise. You couldn't add up cosines. That'd be really weird if you could add up sines. So no big surprise. You also cannot add up sines. So we get these identities. They look similar to the cosine identities, but slightly different. The sine of a plus b goes sine a, cosine b, and now look, when there's a plus here, there's a plus here, cosine a, sine b. And sine of a minus b, identical, sine a, cosine b, minus cosine a, sine b. So we've got those two identities for adding up sines. And now if you look at the title, you think, well, wait a minute, that was sines. We're also going to talk about tangents. And so let's look at the next page and get the tangents too. And again, just like with cosines, why would you want to use these? We'd use these to get exact values for things like 15 degrees or 75 degrees or 105 degrees. And you'll also find they're used in calculus from time to time. These will come up once in a while. Okay, then, since we've done cosine and sine, a logical question is, what about tangent? In tangent, you could easily derive the tangent of a plus b. Remember, tangent is sine divided by cosine. So you could derive it and simplify it yourself. It turns out when you do, you end up with this nice formula. So the tangent of a plus b is the tangent of a plus the tangent of b all over 1 minus tangent a tangent b. So there's a plus here. Look, there's a plus on top and a minus on the bottom. Look, when there's a minus here, there's a minus on the top and a plus on the bottom. The tangent formulas I'm not going to have you memorize. You will need to know how to use them, but you won't have to have those memorized. Okay, let's practice these a little bit. And again, when we're doing these, you have to remember your chart that we had from chapter 1. And your chart has sines and cosines in it. It also has tangents in it. We don't need the tangents yet, so I'm not going to put those in here. We've got the sine, we've got the cosine, and those good old values with 0 degrees and 30 degrees and 45 degrees, 60 degrees, and 90 degrees. And again, we don't really use the 0, 90 in these problems, but it doesn't hurt to put them in there. Sine was the increasing function, went from 0 to a half, root 2 over 2, root 3 over 2, and 1. The cosine was the decreasing function. Goes in the exact opposite order here. Okay, so we get a problem like this. Sine of 105 degrees. You look over at your chart. How would I get 105 degrees? Why don't I go with 45 plus 60? And then go back to your identity for your angle addition identity for sine. Let's go back and see what that is, just in case you forgot it. So it is right here, guys. Sine of a plus b goes sine a cosine b plus cosine a sine b. See if we can go back to our problem here. So it goes sine a cosine b plus cosine a sine b. And once you've written your formula, it's just a matter of looking these values up in your chart. Sine of 45, root 2 over 2. Cosine of 60 is a half. Cosine of 45 is root 2 over 2. And the sine of 60 is root 3 over 2. And again, just like the cosine section, when you multiply square roots, I get square root of 2 over 4. Here I get the square root of 6 over 4. The two square roots are different. You can't add those up if they're different. You get square root of 2 plus square root of 6 the whole thing over 4. Looks very similar to our other answers, which is no big surprise because in our chart, look at the sine, look at the cosine. Those are very similar values. So it's no big, hopefully no big surprise here when we're doing sines and cosines, 105 or 75 or 15. Those answers come out looking very similar to each other. All right, not bad. Let's try a tangent one. And a tangent one, we need to know our values for the tangent. And so let's put just a little chart here for our tangent values. See if you remember those. We had 0, 30, 45. These are all degrees. 60, and 90. And again, we don't really use the 0 and the 90, but let's just fill it in anyway. The tangent was also an increasing function. It started at 0, and then it was a square root of 3 over 3, and then it was 1, and then it was a square root of 3. And down here it was undefined. So hopefully we won't use that 90 often, because that doesn't have a value. Okay, tangent of 105. How do we get that? Same way we got the sine of 105. That's going to be the tangent of 60 plus 45. We can't just add up these trig functions. Too bad we can't. But instead we'll use our identity. So let's look at this one. And again, this one you don't have to have memorized. You do have to know how to use it. So what does it go? Tangent of 45 plus 60 goes tangent of A plus tangent of B all over 1 minus tangent A tangent B. And you've got your sheet there. So it'll be a little bit easier for you. So on the top it was tangent of A plus the tangent of B all over 1 minus the tangent of A tangent of B. And again, once you're there, it's just a matter of looking up these values in your chart, and there might be a little algebra you need to remember from time to time. But let's go through. Tangent of 60 is the square root of 3. Tangent of 45 is 1. I get 1 minus the tangent of 60 is the square root of 3. Tangent of 45 is 1. Simplify a little bit. I get the square root of 3 plus 1 all over 1 minus square root of 3. Okay, and again, trig is always a good class to study, but one reason is it reminds you of your algebra. Remember algebra, the rule was don't ever leave square roots in the bottom of a fraction. And in this case, when it's 1 minus the square root of 3, we multiply by the conjugate. So we'll take the top and bottom times 1 plus the square root of 3. So I look at the bottom, it's 1 minus the square root of 3, and the conjugate I just changed, since that's a minus sign, I changed that to plus. It's just a coincidence that it turned out to be the same thing as the top. That's not the reason I choose that. I look at the bottom, it's 1 minus root 3, I multiply by the conjugate, which is 1 plus square root of 3. Okay, let's see what we get. Let's see what we get on the bottom. I'm going to FOIL this out. First gives me 1. Outside, look at that, it gives me square root of 3. Inside gives me minus square root of 3. So look, the square roots are going to go away. And last, root 3 times root 3 is 3. There's a negative sign, so it's minus 3. On the top, FOIL this one out. Kind of a funny order, but it'll work. First gives me root 3. Outside, root 3 times root 3 is 3. Inside gives me 1. And last gives me a root 3. Okay, let's combine like terms here. Let's do the bottom first. And do you notice the square roots of 3 cancel out? And I have 1 minus 3 is a negative 2. On the top, combine like terms. 3 plus 1 is 4. That's those two right there. And I have a square root of 3, and a square root of 3 gives me 2. Square roots of 3. Divide everything by 2, and it looks like a negative 2 minus square root of 3. All right, surprised that was negative? No, we're in the second quadrant. A smart. Sine is positive. Tangent's negative in the second quadrant. So the negative part of the answer hopefully is not a big surprise. Okay, that's the basics of this section. There's more to it, but this certainly gives you the basic ideas of it. So this is a good spot to stop our first video.